Welcome back, grade 12s. We will now move to tutorial problem number 3. Remember, we are doing differential calculus, rules of differentiation. So far we've done 2 problems. I will now do tutorial problem number 3. This problem, it was adapted from June 2017 KwaZulu-Natal paper 1, and it was question 8. Now, if you check 8.1, it says given f of x is equals to 2 over 3x, determine the derivative. The derivative from first principles. I believe now you're starting to see the order in which these problems are being asked. The first sub-question of calculus, it will be first principles, and then followed by questions where you apply straight your rules of differentiation, and then you will see when we continue with this chapter, we will start looking at what we call cubic graphs. We will apply rules of differentiation and the principles of calculus to solve cubic graphs. And later, towards the end of this chapter, we will look at what we call application of calculus. Okay, now let's start with 8.1 for this problem. So we are given that f of x, remember it can be this notation, this f of x, it can sometimes be h of x or g of x. It's not always that it's f of x, it's just that they like f of x. F of x is equals to 2 over 3x. Okay? Now, since it's first principles, we know that we have to use the long method. And if you check your formula sheet, you will be given this formula. It says f prime x is equals to the limit as h approaches 0, f into x plus h minus f of x divided by h. If you can recall, if you are given f of x is equals to 2 over 3x, and you are asked to determine f of x plus h, what does this mean? It means that from this equation where you see x, you now substitute it as x plus h. So this will be 2 over 3 into x plus h. Okay, so that is what we're going to do here, and then simplify. So this will continue being limit as h approaches 0. Remember this limit as h approaches 0, you write it continuously until you get to a point where you are substituting your h as 0. But at this stage, we can't substitute 0. I will show you why we can substitute this as 0. Now, f of x plus h is 2 divided by 3 into x plus h, close bracket, minus, what is f of x? F of x is the same as 2 divided by 3x. Now, we can agree that this whole thing is divided throughout by h, right? Okay, but instead of writing divide by h, I will just put the sign there that it's 3, just a different notation. Now, the reason why something's wrong here. Okay, yeah, it's fine. The reason why we can't substitute from this moment, we can't substitute h as 0 is because if you put 0 there, it means, remember, this means that everything is divided by 0, divided by h. So we know that in maths, if you have an equation or an expression that is divided, or any number divided by 0, it's undivided. So at this stage, we can't substitute 0. So we have to simplify this first until we get rid of this h. Okay? Now, I believe you also know that if divide by h can also be written as multiply by 1 over h. We call that tips and times. Okay, so this is the same as writing this as multiply by 1 over h. Okay, so that's what I'm going to write, because I don't want to have more than so many divisions. So it's better to eliminate one division and write it as as a multiplication. Okay, so I will write this as 1 divided by h. I will continue with my simplification. This is h approaches 0. Now I'm going to simplify whatever that is inside the bracket. Now let's see this. If you have 5 divided by x plus 10 or 17 divided by y, and we are asked to simplify this. If the first thing we must get is our LCD. So since x and y are not the same, our LCD will be the same as taking x times y. So this will be x. Then this will cancel x. I'll be left with y. Y times 5 is 5y. Plus y will cancel y. I'll be left with x. X plus 17 is 17x. Okay. Sorry. So that's the principle that we're going to use here. So my LCD here will be the same as taking 3 into x plus h multiplied by 3x. Okay. Now I just cross multiply. If you can check here, x, y, x and y, and then here just cross multiply, because 5 times y is 5y, and then 17 times x is 17x. So I will also cross multiply here to make my life easy. So this will be the same as, what is 2 times 3 into x plus h? 2 times 3 is 6, so it will be 6 into x plus h. No, that's not the correct way of doing it. You start with the 2. 2 times 3 is 6, so it will be 6x. 2 times 3 is 6 into x plus h. Everything is multiplied by 1 over h. Now I'm going to remove the bracket. Limit as h approaches 0. From the top, 6x. If I remove the bracket, remember there's a bracket there. So this will be the same as 6x minus 6x minus 6h. Divide by, from the denominator, I'm not going to remove the bracket for now. This will remain as x plus h multiplied by 3x. Okay, remember everything is multiplied by 1. Now, as I already grade 12s, when you get to this point, you can see if you've already made a mistake or not, because all the terms that do not contain an h, when you get to this stage, this level or this step, all the terms that do not contain an h, they must cancel each other. So 6x will cancel minus 6x. Basically, they add up to 0. That's why we say they cancel. And then you can also see that you'll be having one term at the top, which is minus 6h. This 6h, the h will cancel this h. I'll be left with what? Limit as h approaches 0. I'll be left with minus 6 divided by 3 into x plus h, all multiplied by 3x. That's what I'm left with. I don't even have to write the square brackets because it will be multiplied by 1 outside. Okay. Now that I don't have any division, I don't have divided by h here, I can substitute h because my equation is not going to be undefined. So I'm going to now say this will be minus 6 divided by, now, okay, before I explain that, x plus 0 multiplied by 3x. Now you can see here, now I use a different color to show that now I'm substituting my, let me extend my page. Okay, I use a different color to show now that I substitute h as 0. Okay, and also I didn't write my limit as h approaches 0. So this is where you stop writing your limit as h approaches 0. Okay, now it's a matter of simplifying. Go back to my rate. Minus 6, and then this will be 3 times x plus 0 is x. So this will also be times 3x. Then my final answer will be minus 6 divided by 3x times 3x is the same as 9x squared. 9x squared. I can also continue with my simplification and say 3 goes in there 3 times and it goes there 2 times. And then my final answer will be minus, the final answer will be minus 2 divided by 3x squared. That will be the final answer. We will now move to question 8.2.1. So 8.2.1, it says I guess the question says determine or calculate, yes, determine f prime x if f of x is equals to 3 into x squared minus 5 all together to the exponent of 2. So it says we are given f of x is equals to 3x squared minus 5 squared. Sorry. Now, if you look at the mark allocation, it's 4 marks. So it shows that we can't just go straight into finding the derivative. We have to do a couple of simplification first. And as I already said, at this level, you can't differentiate when you have brackets. So we have to get rid of these brackets first. Okay, so I'm going to start by simplifying. So this will be 3 into x squared minus 5. We know that this squared means the bracket times 2. So this will be x squared minus 5. Okay, is equals to 3. I'm going to FOIL whatever that is inside the bracket, but not forgetting that there's a 3 that is multiplying everything after simplifying whatever that is inside the bracket. So I must put everything inside a square bracket to show that I'm dealing with the first ones, and then I'll come back and distribute the 3. So remember, FOIL, first, outer, inner, and then last. Okay, so x squared times x squared is going to be x to the power 4. Remember, when multiplying powers of the same base, you have the exponent because it's x squared multiplied by x squared. X 2 plus 2 is 4. Okay, so it's x to the exponent 4. X squared multiplied by negative 5 is going to be minus 5 x to the exponent of 2 is the same again, minus 5x squared. Negative times negative is positive. 5 times 5 is 25. Now I'm going to simplify right inside the bracket again. 3 into x to the power 4 minus x squared and minus 5x squared are like terms. So minus 5 is minus exponent 2 plus 25. Okay. Now I'm going to distribute and multiply everything inside the bracket by 3. It's going to have 3x to the exponent 4 minus 30 x squared plus 75. Now that I don't have brackets, I don't have square roots, I don't have fractions, and I don't have variables at the denominator, since I don't have fractions, I can now start applying rules of differentiation. And as I've shown you, I'm going to put a star here to show you that now I'm starting to differentiate. Remember, you don't have to write this, I'm only showing you. Now we ask ourselves, what or which notation do I have to use? We go back to the question. The question says f prime x. So the notation for differentiation for this question is f prime x. Now I apply my rules of differentiation. It's going to be 3 times 4 multiply 4 minus 1 minus 30 times 2 times x 2. This is a constant, so the derivative of a constant is 0, so it's plus 0. Now I simplify. 3 times 4, it's 12 x to the exponent cube minus 30 times 2, it's 60 times x. 2 minus 1 is 1, so it's 1 there, and that will be your final answer. Now let's move to 8.2.2. Okay, 8.2.2. We are given x squared minus 3 is equals to the cube root of y. For 5 marks, you can see that we have to do a couple of steps, 4 or 5 steps until we get to the answer. So, and we are also guided by this notation, dy dx. So we are differentiating y in terms of x. So we must make sure that before we apply rules of differentiation, we make y subject of the formula. Okay, so I'm going to take it one step at a time. So I'll have x squared minus 3 is equals to y to the exponent 1 over 3. Remember, there's a law for sets that says if you have a to the root of bm, this is the same as b to the exponent m over a. No, sorry, not b over a, but a over m. No, actually it was right. M over a, yes, m over a. Okay. So yes, that's what I did here. Now, remember I want to make y subject of the formula. Now the question is, how do I get rid of this 1 over 3 at the exponent? So the only way I can get rid of the, remember if it was y squared is equals to 2x plus 5, I was going to apply square root on both sides and say square root, then the square root will cancel the square, y is equals to the square root of 2x plus 5. Okay, but now it's not that simple because it's 1 over, the exponent is 1 over 3. So what I'm going to do is, remember if I have 1 over 3, what can I multiply this 1 over 3 with so that the answer that I get is 1? I can only do this if I multiply this by 3 divided by 1, because 3 will cancel 3, 1 will cancel 1, then 1 is equals to 1. Okay, so I will apply the same knowledge here. So I'm going to multiply this by 1 by 3 over 1. What I do on the left, I must also do on the right. But here I must make sure that I put everything inside the same bracket. So this will be cubed. Okay, now when I simplify this, this will be, remember this will cancel that, then I'll be left with y on one side as a term, as a variable, and then here I'll be left with x squared minus 3 to the exponent cubed. Now because of time, for you to simplify this, you have to open 3 brackets and then do your FOIL, and then you will end up with y is equals to x to the x minus 9x to the exponent 4 plus 27 x squared minus 27. The task as a grade 12 to make sure to solve this on your own until you get to this level. Okay, now everything has been simplified. I can start applying rules of differentiation, and then I was given the notation there, so I can show here with a star that I'm applying rules of differentiation, and the notation is dy over dx is equals to 6 times x to the exponent 5. I believe you know that I minus 1 from the 6, minus 9 times 4. 9 times 4, it's 36, yes, 36, multiplied by x to the exponent 3. Remember the 3 comes from 4 minus 1, plus 27 times 2, 27 times 2, it's 54, multiplied by x. Remember, it's 1 because 2 minus 1 is 1. And then the derivative of constant, it's 0. And that will be the answer for this question. Thank you.